Hello, I am going to design a broadband microstrip antenna using IE3D. The steps involved in IE3D are as follows. The antenna that I am going to design, the design of the antenna is this. We start with the design. Zealand Program Manager, IE3D, micro-grid, file, new file. We need to add a substrate. The thickness of the substrate will be 1.6. The dielectric constant will keep it as 4.4. Loss tangent will be 0.01. Okay. The units are in millimeter. We go to the ground. We convert this. We can make the conductivity as 0, real part of the conductivity. Okay. This finishes off with the basic parameters. Okay. Now we start with the patch design. We go to the rectangular patch. The coordinates of that will be 0, 0. We'll first design the ground plane. For that the z coordinate will also be 0. The length of the patch is 40. The width of the patch is 60. Okay. We press all so that we can view the entire thing. Now we will make a slot in the ground plane. For that again we take a patch, give the coordinates and XOR it. The coordinates for the x is -15, y coordinates is -19. The length of the patch is 5 and the width is 22. The z-axis should also be 0. Okay. Select them, right click, XOR. So we have made successfully a slot in the ground plane. Now we move on to the next part, that is the patch. For that the coordinates x and y is 0, 0. Z coordinate is 1.6 because we have taken the height as 1.6. The length is 30. Width is also 30. Okay. So this is the patch. Now we need to cut a C-shaped patch. So for that we again put a patch over here. The coordinates, x coordinates for that will be 2.5, y is 0, the length is 25, width 20. Okay. Select them, XOR them. So this has made the C-shaped patch. Now we need to put the feed. For that again a rectangular patch. The coordinates, x coordinate for that patch will be 2. The y is 0. The length of this patch is 20. The width is 16. Okay. Fine. Now one more patch which is required for the feed. The x coordinates of that will be 16, y is 0, the length of it is 2, width is 4. Okay. Now the next step is go to edit, select the vertices, go to advanced edit, cut polygon on edge. The width will keep it as 2 as per the design. Depth will take it as 1. Okay. Similar thing on the next page. Go to edit, select vertices, advanced edit, cut polygon on edge. The width is 2, depth is 1. Okay, done with it. Now we'll just zoom it a little so that we can select the inner vertices. Again go to edit, select the vertices. We'll be selecting the inner vertices. Go to advanced edit, continuous straight path. The path that we require is 3, so that depth is 2 on both the sides, so we'll take the path as 5. Width still remains 2. Okay, now we select all the 3 areas and merge them. Merge. Done. Same process we carry out on the other side as well. Go to edit, select the vertices, go to advanced edit, cut polygon on edge. We keep the width and depth as same. Okay, again select vertices, select the inner vertices, advanced edit, continuous straight path. Now the length over here will be 4. Okay, again select both the designs, merge them. So this is done all. Next thing, we need to insert the port. So we go to port, define port, advanced extension, OK, and click on the edge. Now we need to disable the port. We go to process, display meshing. The highest frequency that we are going to take is 3 because we are expecting the resonant frequency to be around 2 megahertz. So, okay, continue. Fine. Now we go to process and start the simulation. For the first, we need to save the geometry. First, we'll save the geometry. Save. Go to process, simulate. The highest meshing frequency we have kept it as 3 gigahertz. We need to enter the starting and the ending frequency. We'll take it as 1.5 as the starting frequency. The ending frequency will take it around 2.5 gigahertz. Number of steps will be 151. Okay. We click on the current distribution and the radiation pattern. Okay, and start with the simulation. So this starts off with the simulation. I have already done the simulations and the results are available with me. I'll just show the results. The results are, this is the VSWR curve. This is the total field directivity versus the frequency curve. This is the S11 parameter curve, the Smith chart for the design, and this is the current distribution that was available after the simulation. The bandwidth that I get with this design is around 419 megahertz. Thank you.